Here we'll go over how to graph a piecewise function, which combines all of the techniques we've learned so far. To begin drawing a piecewise function, we'll need to split our picture up into pieces based on the conditions we've been given for each piece. You'll notice that we have piece A, B, and C. Piece A is in charge anywhere x is less than -4. So we'll begin by marking down where -4 is on the graph and drawing a line at -4. This orange line that I'm drawing now marks where piece A ends and piece B begins. Everything to the left belongs to piece A, and then the next region belongs to piece B. However, piece B is in charge from -4 to +2. Therefore, we're going to continue marking the graph over on the right, and we'll draw another orange line at +2. This means anything between these two orange lines belongs to piece B. Everything that's to the right of that is everything greater than 2, belongs to piece C. Therefore, in region A, we're only graphing this first line, y equals 2. In the middle, for piece B, we'll be graphing y equals absolute value of x plus 1. And then for piece C, we will be graphing y equals x squared minus 4. Let's begin with piece A. We're going to need to select some x values to graph for piece A. The only x's that we are allowed to use are x's that are less than -4. However, since -4 is part of the boundary condition, let's first try to find what y is when x is -4. We'll just have to remember that since we have a less than sign, that means this will be an open circle. Now, our y in region A is just 2, and notice there is no x in that function, so y is always 2 anywhere in region A. Therefore, we can say our first point will be -4, 2, and it will be open. We'll place an open circle at that position. Then, let's pick another x, but make sure that it's to the left of -4. So I could continue marking points. We'll try -5. Doesn't really matter what you do here as long as it's to the left of -4. However, the y is still 2 because the y does not depend on x. Therefore, our next point will be -5, 2. Since that's not on the boundary, that's definitely closed. Now we'll connect the dots and draw a line pointing towards the left. The reason why I'm making it point toward the left is because I'm not allowed to get into region B. I can only go left from this orange line, -4. If I went any further right, I'd cross into region B, and that's a completely different graph. That graph is y equals absolute value of x plus 1. Now notice my boundaries for region B are at -4 and 2. So let's definitely take x equals -4 and x equals 2 and see what y that gives us. Our y will be equal to absolute value of x plus 1. So I'll have -4 plus 1 and 2 plus 1. If I take -4 plus 1, I'll have absolute value of -3, which is 3. Therefore, my point will be x equals -4, y equals 3. Again, since that's on the boundary and we have a less than sign, that will be open. We'll mark that third point on our y-axis and put an open circle on that -4 boundary. Now, if I do the math at x equals 2, we'll have absolute value of 2 plus 1, which is also 3. So my next point is 2, 3. That will also be open. Now, since I have an absolute value function, let's also get the vertex. If you watched my previous video, in order to get the vertex, we're going to set the inside of the bars equal to 0. Therefore, we're going to say x plus 1 equals 0. And if we solve that, we will end up with x equals negative 1. Therefore, our point will be negative 1, comma 0. Since this is not on the boundary, it will definitely be closed. Now region B is complete. All that's left to graph is region C. Our region C begins at x equals 2, so let's definitely do that one. We'll also need another x that is to the right of 2, so let's try x equals 3 also. Again, it doesn't matter what x you do as long as it's to the right, but I'm going to pick one that fits better on the graph. If x is equal to 2, y will be equal to x squared minus 4. Let's put in that x is equal to 2 and then do it again for x equals 3. So 2 squared is going to be 4, minus 4 will give us 0, and so our first point will be 2, comma 0. Since that 2 is on the boundary, it will be open. Then when we plug in 3, we'll have 3 squared minus 4. 3 squared is 9 minus 4, which is equal to 5. Therefore, our final point will be 3, comma 5, and since this is not on the boundary, this is definitely closed. So we'll make one more mark here for 3, and then some more marks on our y. We will put a closed dot at 3, comma 5, and since this is quadratic, we'll draw this as a curve. So you can see that drawing a piecewise function is similar to drawing any other graphs. We just restrict each piece to its corresponding x values. When we graph these piecewise functions, we make sure to plug in the boundary conditions. So whatever x's are in the boundaries, we'll plug those in for each piece they're a part of. And if you're on the far left or the far right, you'll have to pick at least one more point in order to finish the graph. This is why for piece A we did negative 4 and negative 5, where negative 4 was the boundary and negative 5 was extra. And then for piece C we used positive 2 and positive 3. Positive 2 was on the boundary and 3 was our extra. For piece B we used negative 4 and positive 2. Those were both boundary conditions for piece B. And then in order to figure out where we have the vertex, we had to do a little bit of math to figure that out, and we found that was at x equals negative 1. That was our extra point for piece B.